But how is such an event even possible? What would it mean if Pluto and Neptune did crash? Is this just cosmic fear-mongering, or is there something we should genuinely be worried about? To understand this potential disaster, we must look at Pluto's orbit. Unlike other planets, Pluto's journey around the Sun is unique. It takes an extraordinary 248 Earth years to complete one orbit. Since Pluto's discovery in 1930, it hasn't even finished a single loop. Even more bizarre is the fact that Pluto's orbit is not a perfect circle like most planets. Instead, it is stretched out into an elongated oval, and to add to the complexity, it is tilted at a steep 17 degrees compared to the orbits of other planets. In other words, Pluto's orbit is a chaotic mess. Perhaps the most alarming part of Pluto's orbit is the fact that it crosses Neptune's path for about 20 years during each of its orbits. For these 20 years, Pluto is actually closer to the Sun than Neptune is. But despite this oddity, the two planets have managed to avoid colliding. How is this possible? The answer lies in a combination of gravity and some remarkable cosmic mathematics. The interactions between the planets in our solar system are incredibly complex. The reason Pluto and Neptune haven't crashed into one another is due to a delicate cosmic balancing act. After Pluto's discovery, astronomers were initially perplexed by its orbit, as it didn't fit the expected pattern of the other planets. In the decades that followed, scientists realized that even though Pluto and Neptune's orbits cross, they never actually collide. This is because the gravitational interactions between Pluto, Neptune, and the Sun work in such a way that they maintain a safe distance from each other. To predict their future movements, scientists use complex calculations that take into account their current positions and the gravitational forces acting upon them. Terms like asynchronous oscillation, orbital drift, and VZK wobble come into play when describing how these interactions keep the planets from colliding. The concept of asynchronous oscillation refers to the phenomenon that allows Pluto and Neptune to pass through each other's orbit without a crash. Orbital drift is the subtle motion that causes Pluto to pass slightly above or below Neptune's path. The VZK wobble refers to the gravitational influence exerted on both planets by the Sun, which helps keep things in balance. However, even though these stabilizing forces have worked for billions of years, the system is not foolproof. In the late 1980s, scientists used computer simulations to explore Pluto's orbit and found that, despite its stabilizing mechanisms, Pluto's path could still be unpredictable. Interestingly, despite these forces keeping Pluto's orbit relatively stable, small changes at the beginning of its orbit could lead to huge effects in the future. Scientists have been using computer models to predict what might happen to Pluto's orbit in the long term, and these models have shown that small changes in Pluto's speed or position could cause its orbit to become unpredictable. These models suggest that, although Pluto's orbit has remained stable for billions of years, it's not completely immune to future disruptions. These tiny fluctuations could potentially alter the entire course of Pluto's orbit in ways we don't fully understand. Back in the 1980s, researchers used these computer models to study Pluto's orbit and came to a surprising conclusion. While Pluto's orbit is generally stable, it can still exhibit some unpredictable behavior. In fact, the models showed that small differences in Pluto's position or speed could lead to significant changes in its future path. However, despite these potential fluctuations, Pluto's orbit has remained surprisingly stable over the course of billions of years, which raises the question: what is it that keeps Pluto's orbit from spiraling out of control? And could that stability change in the future? Even though Pluto and Neptune are able to avoid a collision due to the specific gravitational dance they perform, scientists have started to wonder if there's a potential for that to change over time. For billions of years, the two planets have remained in this delicate balance, but the solar system is a dynamic place, constantly undergoing changes. Over incredibly long periods of time, the orbits of all celestial bodies, including Pluto and Neptune, could slowly shift due to various gravitational interactions. These shifts are so subtle that they aren't noticeable over a short timescale, but if they continue for millions or even billions of years, they could lead to changes in their orbits that could eventually cause them to collide. That's what has some researchers worried, especially considering the unpredictable nature of space. Could Pluto's orbit somehow change, putting it on a path that leads directly into Neptune's orbit? What would happen if that did occur? One thing to keep in mind is that Pluto and Neptune's orbits are not just influenced by each other. The gravitational pull of the other planets in the solar system, especially the giant ones like Jupiter and Saturn, can also affect the paths of these two bodies. Jupiter, in particular, is a powerful influence on the outer solar system due to its enormous mass. Any small gravitational nudge from Jupiter could change the trajectory of Pluto's orbit over time, and if that happens, it could trigger a chain reaction that leads to an eventual collision. But here's the twist. For all of the potential changes in Pluto's orbit, the chance of an actual collision is still very small. So small in fact that it might not happen for billions of years. But just because it's unlikely doesn't mean it's impossible, and that's why scientists like Neil deGrasse Tyson and Michio Kaku are paying close attention to the possibility. One possible scenario that could lead to Pluto and Neptune colliding involves a concept known as orbital resonance. In simple terms, orbital resonance happens when two objects in orbit around the same star exert regular, periodic gravitational influences on each other. This can occur when their orbits are synchronized in such a way that they interact with each other in a predictable pattern. In the case of Pluto and Neptune, their orbits are in a 2:3 resonance. This means that for every 2 orbits Pluto makes, Neptune makes 3. This resonance is a big part of why the two planets don't collide, as it helps keep their orbits stable. However, over time, this resonance could be disrupted by various factors, such as gravitational interactions with other planets or the influence of passing stars. If the resonance were to break down, it could lead to a situation where Pluto's orbit becomes more erratic, potentially bringing it into Neptune's path. Again, while this is an unlikely scenario, it's still a possibility that scientists have to consider. But let's not forget the potential catastrophic consequences of such a collision. If Pluto were to collide with Neptune, it would be an event of unimaginable scale. The impact would likely release an incredible amount of energy, enough to cause major disruptions in the solar system. Given that Neptune is a gas giant, its dense atmosphere and powerful gravitational field would likely cause Pluto to break apart long before it even reaches the planet's core. In fact, the collision would probably result in a massive explosion, with debris from both Pluto and Neptune scattering across the solar system. The shock waves from the impact could even reach other planets, causing disturbances in their orbits. While this may sound like something out of a sci-fi disaster movie, it's a scenario that could have serious consequences for the solar system as a whole. Another possible outcome of Pluto and Neptune colliding is the potential for the creation of new moons or other celestial objects. If the two planets were to collide, the debris left behind could coalesce into smaller moons or asteroids, forming a new group of objects orbiting Neptune. This wouldn't be the first time something like this has happened in the solar system. In fact, many of the moons of the gas giants are believed to have formed from debris left behind by collisions between celestial bodies. If Pluto and Neptune were to collide, it could potentially lead to the formation of a whole new group of moons that would orbit Neptune in the future. However, even though this scenario sounds catastrophic, it's important to remember that the odds of a Pluto-Neptune collision are still extremely low. The unique orbital dance that Pluto and Neptune engage in, along with the stability of their orbits over billions of years, suggests that a collision is an unlikely event in the short-term future. Still, the fact that such an event is possible, however remote, raises fascinating questions about the stability and future of our solar system. Could we one day witness a cosmic collision of this magnitude, or will the solar system continue its delicate balance for billions of years to come? As scientists continue to study Pluto's orbit and its interaction with Neptune, they'll be able to refine their models and predictions. The more we learn about the distant reaches of the solar system, the more we can understand how the objects in it move, interact, and evolve. This research is also important because it helps us understand the broader dynamics of planetary systems, not just in our own solar system but in others as well. Every time scientists like Tyson and Kaku raise the possibility of a Pluto-Neptune collision, they're prompting us to think more deeply about the forces that shape our universe. And while the likelihood of such a collision may be low, the mere fact that it's a possibility underscores how little we truly know about the long-term behavior of our solar system. In the grand scheme of things, this event may be billions of years away, but it also serves as a reminder that the universe is always changing. Even the most stable systems can experience shifts over time. The possibility of Pluto and Neptune colliding raises the question: what other seemingly stable parts of the universe are also at risk of dramatic change in the distant future? Only time will tell, but as long as scientists continue to explore and question, we'll keep learning more about our cosmic neighborhood. And who knows? Maybe one day, future generations will look back on our era as the one that first raised the alarm about the possibility of a Pluto-Neptune collision. For now, though, we can rest easy knowing that the chances of a collision between Pluto and Neptune are incredibly slim. It's just one more fascinating aspect of our solar system that reminds us how dynamic and ever-changing the cosmos truly is. Whether or not Pluto and Neptune eventually collide remains to be seen, but one thing is certain: the study of our solar system is far from over, and as we continue to explore, there will always be new mysteries to uncover. The puzzle of questions surrounding Pluto and its orbit is what keeps astronomy so exciting. Despite his optimism about space exploration, Neil deGrasse Tyson remains concerned about a potential Pluto-Neptune collision. While Tyson is hopeful about the universe's mysteries, he's far from carefree when it comes to Pluto's future. He recognizes that while Pluto has been safe so far, the universe operates on a delicate balance, and even small changes over time could lead to disastrous consequences. Tyson explains that Pluto's orbit, especially where it crosses Neptune's, is a complicated dance, one that may not stay in sync forever. These two planets have orbits that intersect, but the forces keeping them from colliding are fragile. Tyson's concern is not without merit. Even tiny disturbances in Pluto's orbit could have significant effects. If these issues gradually build up over thousands of years, they could eventually lead to chaos or, worse, a planetary collision. However, Tyson is quick to reassure that this won't happen anytime soon. It would take an incredibly long time, far beyond what humans can comprehend. Despite this reassurance, Tyson stresses the importance of continuing to monitor and study Pluto's orbit, emphasizing that the dynamic nature of the universe means we can never be too sure of what might happen in the distant future. Tyson isn't the only expert with concerns about the possible instability of planetary orbits. Michio Kaku, a renowned physicist, shares similar worries about the astronomical chaos that could emerge from interactions between planets. Like Tyson, Kaku is in awe of the universe's wonders, but he also understands that planetary orbits are incredibly fragile. Over time, even the smallest forces can cause huge, unexpected shifts. Both Kaku and Tyson agree that space exploration remains crucial, as understanding the invisible forces at play in the cosmos will help us comprehend not just the present, but the future of our solar system. The story of Pluto's uncertain future serves as a reminder that our understanding of the universe is always evolving. Every new discovery leads to even more questions, pushing the boundaries of our knowledge. As space science progresses, the small but real possibility of a Pluto-Neptune crash reminds us that the universe is full of surprises. Even paths that seem calm and predictable can change drastically over time. This lesson highlights the need for continued observation and study of the cosmos, as we try to unravel the many mysteries still hidden in the stars. Pluto's tale is a curious one. Once considered a planet, it was relegated to the status of a dwarf planet, hanging out far from the inner solar system. But recently, some prominent scientists, including Tyson and Kaku, have brought Pluto back into the spotlight, though not in a good way. They are raising alarms about the possibility that Pluto is on a collision course with Neptune. It may sound like a dramatic theory, but these scientists aren't just throwing it out as sensationalism. They are using their platforms to draw attention to a legitimate concern, arguing that Pluto's orbit is dangerously close to Neptune's, and even a slight shift could lead to a catastrophic collision. But how is such an event even possible? What would it mean if Pluto and Neptune did crash? Is this just cosmic fear-mongering, or is there something we should genuinely be worried about? To understand this potential disaster, we must look at Pluto's orbit. Unlike other planets, Pluto's journey around the Sun is unique. It takes an extraordinary 248 Earth years to complete one orbit. Since Pluto's discovery in 1930, it hasn't even finished a single loop. Even more bizarre is the fact that Pluto's orbit is not a perfect circle like most planets. Instead, it is stretched out into an elongated oval, and to add to the complexity, it is tilted at a steep 17 degrees compared to the orbits of other planets. In other words, Pluto's orbit is a chaotic mess. Perhaps the most alarming part of Pluto's orbit is the fact that it crosses Neptune's path for about 20 years during each of its orbits. For these 20 years, Pluto is actually closer to the Sun than Neptune is. But despite this oddity, the two planets have managed to avoid colliding. How is this possible? The answer lies in a combination of gravity and some remarkable cosmic mathematics. The interactions between the planets in our solar system are incredibly complex. The reason Pluto and Neptune haven't crashed into one another is due to a delicate cosmic balancing act. After Pluto's discovery, astronomers were initially perplexed by its orbit, as it didn't fit the expected pattern of the other planets. In the decades that followed, scientists realized that even though Pluto and Neptune's orbits cross, they never actually collide. This is because the gravitational interactions between Pluto, Neptune, and the Sun work in such a way that they maintain a safe distance from each other. To predict their future movements, scientists use complex calculations that take into account their current positions and the gravitational forces acting upon them. Terms like asynchronous oscillation, orbital drift, and VZK wobble come into play when describing how these interactions keep the planets from colliding. The concept of asynchronous oscillation refers to the phenomenon that allows Pluto and Neptune to pass through each other's orbit without a crash. Orbital drift is the subtle motion that causes Pluto to pass slightly above or below Neptune's path. The VZK wobble refers to the gravitational influence exerted on both planets by the Sun, which helps keep things in balance. However, even though these stabilizing forces have worked for billions of years, the system is not foolproof. In the late 1980s, scientists used computer simulations to explore Pluto's orbit and found that, despite its stabilizing mechanisms, Pluto's path could still be unpredictable. Tiny shifts at the start could lead to significant changes down the line. Yet, the simulations also showed that Pluto's orbit had remained remarkably stable for billions of years, offering a sense of reassurance. To further understand Pluto's orbit, scientists ran additional automated simulations that took into account the gravitational pull of other large planets, such as Jupiter and Saturn. These giants help keep Pluto's path steady, with their massive gravitational influence acting as a stabilizing force. It's almost as if there is a cosmic team effort at play, where each planet's gravity works together to maintain the solar system's order. Without these stabilizing forces, things could get chaotic, with planets potentially colliding or being ejected from the solar system. But despite the cosmic team effort, Pluto remains a fascinating case study. Its orbit is far from simple, and the way it interacts with other planets in the solar system underscores the unpredictable nature of the universe. The key takeaway here is that even seemingly stable paths can change, and that even the slightest disturbance could lead to chaos. The fact that Pluto has managed to stay stable so far doesn't guarantee it will remain that way forever. This is why scientists like Tyson and Kaku continue to closely monitor Pluto's orbit. They understand that the universe is constantly shifting, and while Pluto's stability has been impressive, even the smallest changes could eventually tip the balance. So, why the sudden concern from Tyson and Kaku? These two scientists have long been fascinated by the universe's mysteries, but they are also aware of the fragile nature of planetary orbits. While they both remain optimistic about the wonders of space, they also recognize that even the slightest changes in Pluto's orbit could have far-reaching consequences. Tyson, in particular, has long been vocal about his views on Pluto's status as a planet. He argues that the reclassification of Pluto wasn't meant to be an insult but rather a reflection of the evolving understanding of the solar system. However, when it comes to Pluto's future, Tyson is less optimistic. He knows that even a minor disturbance in Pluto's orbit could have catastrophic effects, and he believes it's important to keep studying and observing the planet to ensure we understand the potential risks. Kaku shares similar concerns. He is in awe of the vastness and complexity of the universe, but he too understands the fragility of planetary systems. While the possibility of a Pluto-Neptune collision may seem remote, it is still a real concern that should not be ignored. Both Tyson and Kaku stress that space exploration and continued observation are vital for understanding the forces that govern our solar system. The lesson from Pluto's story is clear. The universe is always shifting and changing, and even the most stable planetary paths can be altered over time. As we continue to explore the cosmos, we must remain vigilant and continue to monitor the skies, for the secrets of the universe are still waiting to be discovered. The James Webb Space Telescope, the most powerful observatory ever built by humanity, has once again stunned scientists around the globe. This time it's not peering into distant galaxies or watching stars explode, it's turned its gaze much closer toward the edges of our own solar system, and what it found there has shaken everything we thought we knew. The target? Pluto, the small, icy world we once called the ninth planet. For decades, Pluto was written off as a cold, frozen rock drifting through space. But now, with James Webb's ultra-sensitive infrared vision, it has revealed a face no one expected. A living world, active, dynamic, and full of secrets. High-resolution images and complex spectroscopic data suggest Pluto may not be a lifeless rock after all, but a complex body with internal activity, shifting geology, and even the potential ingredients for life itself. This isn't just another planetary observation. This might be one of the most important discoveries in the history of planetary science. One of the most eye-opening features revisited by the Webb telescope is Sputnik Planitia, a massive, icy plain shaped like a heart that lies on Pluto's surface. What was once seen as nothing more than a beautiful, flat expanse of nitrogen ice is now being reinterpreted in light of new data. Beneath this frozen surface may lie something astonishing, a vast, subsurface ocean of liquid water, shielded by thick ice and warmed from within. This ocean is not warmed by the sun, which is far too distant, but by the planet's own internal heat, possibly generated through the slow decay of radioactive elements in Pluto's rocky core. If confirmed, This would place Pluto among the very few celestial bodies with an internal ocean, a feature that dramatically increases the possibility of life. Not only would this be a game-changer for our understanding of Pluto, but it would also suggest that the conditions for life are not exclusive to planets close to stars. Life could exist in the coldest, darkest corners of space, if the right chemistry and internal processes are present. Pluto's surface itself, once believed to be ancient and unchanging, is turning out to be anything but static. Thanks to data from James Webb, scientists now realize that Pluto is geologically active even now. Towering ice mountains, some of which rise as high as Mount Everest, dominate the terrain. These mountains are made not of rock, but of frozen water as hard as granite due to the frigid temperatures. Between these mountains lie plains that appear remarkably smooth and uncratered, suggesting recent resurfacing activity. How is this possible on such a small distant object? The answer seems to lie deep below the crust, where internal heat may be driving convection in the nitrogen ice. Like a pot of thick soup slowly boiling, the ice moves and shifts over time, erasing impact craters and renewing the landscape. This kind of geological activity was never expected on Pluto, yet it's happening right now. And it challenges the long-standing assumption that only large, sun-warmed planets can remain geologically alive. Because of all these findings, Pluto is now being compared to other icy worlds in our solar system that may harbor hidden oceans, places like Jupiter's Europa and Saturn's Enceladus. These moons have long fascinated scientists because of their potential to support life beneath their icy shells. But Pluto's story is different, and possibly even more compelling. Unlike Europa and Enceladus, Pluto isn't influenced by the strong gravitational pull of a giant planet, which is known to create internal heat. Yet somehow, Pluto seems to maintain enough warmth to allow for geological activity and possibly even liquid water. This suggests that internal oceans may be far more common in the universe than we ever imagined. If Pluto, without any significant tidal heating, can hold onto an ocean, then perhaps many other small, icy worlds could as well. The search for extraterrestrial life may need to extend to the most unexpected places, the dark, frozen fringes of solar systems, where life might quietly thrive beneath thick blankets of ice. A crucial piece of this complex puzzle is Pluto's largest moon, Charon. At about half the size of Pluto, Charon is unusually large compared to its host, making the two more of a binary system than a traditional planet-moon relationship. They orbit a common center of gravity that lies between them, and this unique setup leads to significant gravitational interactions. These tidal forces could be generating heat within Pluto and Charon's interiors, contributing to their potential subsurface oceans and geological activity. But the connection runs even deeper. Charon shows its own strange features, including a massive system of canyons and unusual reddish spots on its poles. Some scientists believe that these features point to a history of surface eruptions and chemical exchanges between Charon and Pluto. The idea is that materials may have been transferred between them through ancient collisions or escaping gases, creating a system in which the building blocks of life may have circulated freely between two worlds. If true, this binary dance between Pluto and Charon might not just be a gravitational relationship, but a chemical partnership, one that increases the odds of life forming in some hidden niche. Much of what we now understand about Pluto wouldn't be possible without the power of the James Webb Space Telescope. While NASA's New Horizons mission gave us the first detailed flyby images of Pluto in 2015, it was a one-time visit. Webb, on the other hand, continues to observe Pluto from afar, using its infrared sensors to peel back the layers of this icy world. Its ability to detect heat, light, and chemical signatures at extremely low temperatures has transformed our understanding. Webb has now measured subtle temperature changes across Pluto's surface, mapped its seasonal frost cycles, and identified a thin but surprisingly complex atmosphere. This atmosphere is composed mainly of nitrogen like Earth's, but also contains methane and carbon monoxide. These gases interact with ultraviolet light from the sun, creating intricate layers of haze that stretch hundreds of kilometers above the surface. These hazes aren't just pretty, they reveal critical information about Pluto's climate, surface-atmosphere interactions, and possibly even clues about what's hiding beneath the ice. One of the most fascinating aspects of Pluto's thin atmosphere is how it changes with the seasons. Unlike Earth's yearly cycle, Pluto's year lasts 248 Earth years, and its elliptical orbit takes it dramatically closer and farther from the Sun. As Pluto moves closer to the Sun, its surface ices begin to sublimate, transforming directly from solid to gas, and thickening the atmosphere. When Pluto moves away again, temperatures drop, and the atmosphere condenses back onto the surface as frost. This cycle is unlike anything else we've seen in the solar system. It's a slow, epic breathing pattern of an entire world, where the atmosphere vanishes and returns depending on Pluto's distance